Cool. So we are live.
We still have a minute.
YouTube. Okay, it's visible. 6 people are there.
Oh, just 6?
Yes, right now. We can wait for maybe 4 or 5 minutes and then start. It just got to 4, so
Okay. Initially, even I was thinking that I'll wait until in-class meetups start, but then I thought, okay, it's not starting anytime soon, so let me just do it at least one for now.
yes, it makes sense to do this kind of, but again, like depends. So, uh, is Anup Agarwal saying hello?
Yeah,
Is he your friend?
yeah. So basically, he's working with me on my personal project.
Okay. So you want to wait or you want to start?
Let's see. So it'll be you starting with the introduction, or then I just
Yes,
start.
yes.
Yeah,
I will
yeah. So
just
let's start then.
yes. Cool. Hello everyone. Welcome to AWS UG November, Pune November meetup. Today we have with us Vimal, who will be delivering a session on securely managing database connections with RDS Proxy. And like our second speaker, Amit, is feeling under the weather, so he has to cancel his plan. So we will be sticking with the one session for this meetup. And I will hand it over to Vimal. He can start, or maybe you can wait for 1 or 2 minutes and start.
Yeah, okay, let's just give them a couple more minutes and then we can start
Sure.
right at 5:05.
Yes. Cool. I'll just remove myself from screen.
Hello, everyone. Good evening, AWS fans. So let's get started with our meetup. So in this meetup, we'll be talking about securely managing database connection via RDS Proxy. This is not a very new service, but it's still a new service which was launched within the last few months by AWS to properly manage your RDS connections or even your on-prem connections. So before we jump into the topic, I'll just give a brief about me. I'm an AWS Authorized Instructor from over 8 months or close to 10 months now. I also work as a contractor as DevOps Engineer with Modus Create and TopTal. I currently hold 5 AWS certificates, 3 associates, 1 security, and 1 solution architect professional. Najana, so we'll first start with understanding what an RDS is, a very high level overview or a description about RDS. Then we'll talk about RDS Proxy, its limitations, followed by a demo, and we'll end it with a Q&A session. So what is RDS? Most of us would already know it's a relational database managed service, which is provided by AWS. It supports multiple SQL database services like MySQL, Postgres, MariaDB, Oracle, Microsoft SQL Server, and Aurora, where Aurora is their in-house developed database service, which is backward compatible with MySQL and Postgres. The benefit of using managed service over unmanaged or just spinning up your database on an EC2 instance is if you spin up on EC2 instance, basically you have to manage the installation, patching of your operating system, your database files, your libraries, whatever basically you install on that. But when you use the RDS service, the managed service, the only thing which you have to take care of, securing your RDS with proper security groups, NACLs, making sure your database is in private subnet. You just properly optimize your queries. That's what. So you don't have to take care of the management task which you are supposed to do when you either host your database on-prem or on EC2 instance. It has inbuilt support for automated backups, which also allows you to perform point-in-time restore. Along with that, you can secure your database both in transit and rest side encryption. So this was a small overview about RDS. Let's talk about RDS Proxy, why you should basically use RDS Proxy, what are its benefits, and some of its limitations. So it's again a highly available and fully managed database proxy service. So instead of now connecting to your database directly, so you don't point your application to your database endpoint, instead you create a proxy service and you point all your connections via this proxy. So behind the scenes, proxy manages the connections to your database instead of you directly connecting to your database. It intelligently and properly manages your database connection so that you don't have to. So for example, if there are 100 requests parallelly or 200 requests parallelly coming, and your database isn't able to support all those requests concurrently, then RDS proxy will smartly manage it. It will keep your requests which needs to be fulfilled in the queue unless the connections can be established. And once those connections are available for RDS proxy, it will send all those requests which were there in the queue and it will complete your request. So this way it smartly manages, and this is called connection pooling. So it's basically an optimization that reduces the overhead associated with opening and closing connections with keeping many connections open simultaneously. This also reduces the overhead of opening and closing and memory pressure and CPU consumption. It supports both native and IAM authentication, just like RDS itself does. It also supports TLS and SSL connection between client and proxy. So basically, right from your client machine until your database, you can have end-to-end encryption supported along with RDS proxy as well. And it also useful in database failovers, because whenever there is a database failover, and provided you have a multi-AZ deployment, what happens behind the scene is your slave or your secondary database is converted to a master database. And once it converted to a master database, but if you are straight away just connecting to a database, you will have a few minutes to few seconds of a downtime because of that switch. But when you use RDS proxy, it will handle that failover more resiliently behind the scenes. So when the original DB instance becomes unavailable, RDS proxy connects to the standby database without dropping the idle application connection. So doing this helps you to even speed up and simplify the failover process. The result is fast failover that's less disruptive to your application than a typical reboot or database problem. Now, with every service, there are some limitations, but these limitations are taken care by AWS over the course of period. Just like all other services, even RDS proxy initially is not available within all the regions. So if you want to work with RDS proxy, you need to make sure that you select the region where this service is available. It must be in the same VPC your database is in. On top of that, it cannot be publicly accessible, though your database can be, but RDS proxy will never provide you with a public endpoint. It will always be private. So you need to make sure even if you keep it in public subnet or private subnet, it will always be private in nature. You cannot connect it over the internet. Each proxy can only be connected to a single database or cluster. So you cannot have a single proxy connected to multiple databases, whether you're MySQL, Postgres, or even if they are homogeneous collections. It can be connected to only one database or an Aurora cluster at any given point of time. And as of now, it also does not support custom DNS, which means you cannot actually map the DNS which is provided by RDS proxy with your Route 53 CNAME and use it. You'll have to use it as it is, at least as of today. Okay, that was all in the theory. Let's now get to the demo. So I've already created most of the resources which are required for this demo, but I'll still show you guys how those resources are created or what all resources are in place. So I have an EC2 instance, which I'll be basically using for running a Python script, which will make concurrent or parallel requests to my RDS proxy and my RDS database both, and we'll compare how beneficial is using RDS the proxy over the RDS database. I have RDS proxy created as well, but I'll create one for you guys. I'll walk you through. The reason I've created all these resources, but because they consume around 10 to 15 minutes, the database and the proxy, they consume around 10 to 15 minutes. So I just thought to create them before we start our session. And then I have a Postgres SQL database with T3 micro and a secrets manager. Okay. You all must be aware of how to create an EC2 instance. So I'll be only focusing on showing you how to actually create an RDS and how to link it with your RDS database and how to link with the secrets manager and why do we actually need secrets manager. Okay, so once I'm within RDS, I just click on create proxy. I can just give whatever name I want to give my proxy. It doesn't need to be the same name as your databases. Then you select your engine compatibility, whether your RDS is MySQL or a Postgres or MySQL or Postgres Aurora cluster, anyone will do. I have a Postgres database running, so I'll just select Postgres from dropdown. I need end-to-end encryption. So I'll just check the box, which says require transport layer security. From the dropdown, I'll select the database which I created, which is my Postgres database with the name DemoDB instance. That's the only one there. Now I need secrets manager because RDS proxy needs to authenticate for each and every connection it makes with the database. So if it does not have those username and password, which the database is associated with, RDS proxy will not be able to make connection or make any request, execute any operation on our database. So that's the reason instead of hard coding or instead of just providing the values username or password here, we create a secrets in the secret manager and we link it here. So I've created a secret manager already here. I'll even walk you through how to create a secret in the secret manager. It's very simple. You just give it a name. You provide the values for your database, whatever you need, and you create it. It's very simple, but I'll still show you once I go through this proxy one. And then the IAM role, I'll just stick to create IAM role. So I'll let the RDS proxy create an IAM role for me, which basically will have the permission to connect to RDS database and secrets manager so that it can use those secrets manager to fetch the username, password, and other values which are required to connect to database. Now, I'll be using IAM authentication here instead of actually using the username and password. So this is how I'm actually making my RDS connection from my application much secure. So instead of hard coding or fetching my username, password, hard coding it anywhere within the application, I'll use the IAM authentication way. So I'll make an IAM call to the RDS proxy service, which will give me a temporary token, which I'll pass when I am connecting to RDS service. And this way, I'm actually not hard coding my password within the application. So this is how I can secure it. Now, when coming to my subnets, because it is not available in public, so it's better I'll just choose the private subnet. Now, my database is already in the private subnet. So just to know which one is my private subnet, I can just see that the one ending with 7D3 and BC0 are the one private subnet. So I'll remove the other ones. And if you want enhanced logging, you can, and then you just click on create proxy. Now, once you click on create proxy, it's going to take a so you'll have to wait until then. So I'll just click the cancel for now because I already have one ready in working condition. Now jumping to the secrets manager, as I said, it's very easy. So you just click on storing a new secret or creating a new secret, depending on the dashboard screen which you have. Then you just select the first one, which says create credential for RDS database. You can give the username and password, whatever it is. You select your database, and we click next. Let's give our secret a name. And if you want to enable automatic rotation, which means in, let's say, every month, every 6 months, which most of the companies have, they need to follow it because of the compliance. So if you want to enable automatic rotation, you can enable it, associate a Lambda function with it, which will actually go ahead and behind the scenes will actually update these MySQL or sorry, PostgreSQL credentials for you. But as of now, we don't have any such requirement. So I'll just stick to disable automatic rotation. I'll click next, and this was all. So it's this simple to create a secret. Once the secret is created, you can associate it with your RDS proxy. Okay, so I have RDS proxy running. I have my database. I have secret manager associated with RDS, which holds basically my PostgreSQL credentials. And I have an EC2 instance in running state. So now what I need to do is I just need to get shell access, get terminal access of my EC2 machine so that I can run my Python script, which will connect first to my RDS database. So basically it will make around 100, 200, depending on the count to which I provide. It will be making those many numbers of parallel and concurrent requests. And it will show you how many requests failed and how many succeeded, depending on the connections that were available that the application was able to make. And followed by that, I'll run the script again, but this time it will be connecting via the RDS proxy, and we'll see the difference about how the connections are managed and what's the success to failure ratio compared with direct DB connections and via RDS proxy. Okay, so I'll be using systems manager service instead of using the key pair. So I already have proper permissions and SSM agent installed. So I'm within my EC2 machine. So let's just confirm that I'm in the same EC2 machine. So my IP is 192.168.0.8, and I can confirm that it's the same EC2 instance I'm currently in. So I already have a Python script here. I'll just quickly walk through. Oops. Okay, so I'm using a couple of libraries and threads to make those parallel requests. I'm defining the proxy host. So there are two basically functions. One is connectdb, which will just use the database URL followed by the username and password, which are hard coded. It'll open the connection, wait for 2 seconds. I'm not very good with SQL. So the best what I thought I can do is I just keep a sleep of 1 second, 2 seconds, which I can maintain. And this way I will be at least able to see how the performance difference is between DirectDB and via RDS proxy. And then I have a second function which basically uses the proxy host this time, and it uses the token which is generated here. So I'm making a call to RDS and the method name is generate DB auth token. So I'm just passing that token here to proxy. I'm doing the same stuff. Once my connection is open, I'm just adding a sleep of 2 seconds. I close the connection. And in the end, I'm also counting how many of the threads I have been running were successful and how many failed. Okay, so I'll just run this. So if you notice here, the first thing which I'm doing is I'm connecting via database. So the function which I'm calling here is connect_db, which will make a direct connect to my database and not via the RDS proxy. Okay, so we see that many of them failed, with the reason remaining connection slots are reserved for non-replication super user connections. If you belong to database, you will be able to understand them more clearly, but at a very high level. This error is thrown because the amount of connections which your database is limited to can handle at any given point of time has reached. So in short, in summary, only 77 were successful connections and 123 failed. So this is with T3 micro with no additional proxy in between. Now I'll just change my function, which will this time make a call to my proxy instead. I'll clear the screen and I'll run it. Now, this is going to take while in the intro, just 3 seconds, and all those 200 connections were successful. So you see the success to failure ratio, like 120 around, 123 failed when we were directly connecting to RDS. But in case of RDS proxy, all 200 succeeded. I'll run the test again with proxy and let's see what happens this time as well. Seems like this time it's taking some time. Okay, meanwhile, as I'm waiting for the DB connections to succeed, I'll just answer a few questions from the comments. I'll start from the last. Is there any limitation to number of connections on DB proxy? Basically, no. Which one prefers system manager or parameter store AWS? Systems manager is basically so systems manager has multiple components within it. Out of one is parameter store, which you can basically use to store secrets or just your application config. And there are many other services like connecting to your EC2 instances remotely via actually opening port 22 or using the private key. So these are just two components within the systems manager. There are a lot more within that. How proxy manage the connections? Is there any sequence on priority in pooling from create, update, read, or delete? So as the query comes in, they are forwarded to your database in the order they come in. And if all the connections are exhausted with your database, then it basically puts all the requests in the queue. And as soon as the database connections are again released, operations are completed, then your requests which were received in the order, they are sent back to the database. Okay, this time it took quite a long. Might be my internet or something wrong with the proxy, but at least all our database connections succeeded. Now, if I switch back to using database, and if I run the script again, we'll see again, most of them fail. Same count, 123 failed, 77. So this also actually proves that the max number of connections a database can have is 77. But this is okay because my database is currently of T3 micro. If I increase T3 micro from small too small, medium, or large, or even if I migrate it to M5 or R5, depending on my use case, the number of connections in parallel will increase. But again, so let's say if you're using an R5 database or M5 X large database, and you want to make 1,000 parallel requests, but the limit there is around, let's say, 500 or 400. So again, in that case, you can still use RDS Proxy to manage all those 1,000 parallel requests without dropping any of it smoothly. All right, so that was all from my side with demo as well. If you guys have any Q&As, question and answer, few of them I've already answered. I'll pick few more from the comments which I'm receiving. Is there a default connection timeout in proxy and can this be configured? Yes, it can be. By default, it's 30 minutes, but you can bring it down whenever you need it. Then we have, how about spike connections? How this will be handled? Is there any performance issues on the user end? I didn't actually get your question, Prakash. How about spike connections mean?
Okay, so we can we can take the next one while he
Yeah,
explains it maybe. Trustful.
okay, yeah. So can we get the code as reference, which is currently showing? Yes, I can, but I don't know how to share it.
Maybe you can just upload to GitHub and then share the link with me. I can send an email with the link, or we can post it on Meetup as well.
Okay, I'll do that. So I'll post it on GitHub as you said. I'll share a link with Jayesh and he'll share it with you all there.
Cool.
Next we have, is there a default? Okay, I've already answered that. Do
This
AWS
one,
provide access for free tier account? Yeah, AWS does have free tier, but then whenever you start with any of the service, it's always a good practice that you go to the pricing page and you check which all services fall under free tier and what are the limitations or conditions with them.
oh, so the specific question was, is RDS proxy under free tier? Do AWS provide access to RDS proxy for free tier account?
Uh, I'm not basically sure. I've never checked whether it falls under free tier or not, but yeah, you can always go to AWS free tier page. Just Google it, and then you'll get to know whether it falls under free tier or not. Okay, Prakash, for instance, we currently face this issue sometimes when all the users log in at same time, we have DB connections go up to more than 500. Yeah, so that's what I explain here. So when there are too many requests coming in parallel, that's where RDS proxy saves you without dropping any of the connections. It might take a couple more seconds to give the response back, but at least there will be no drop of connections. It will handle those properly. I've tested this script multiple times before as well, and today as well, around 2 to 3 times. But seems like today there is something wrong with RDS proxy going from AWS side. That's the reason it has taken around 130 seconds. But normally it doesn't, because I've actually implemented it in with multiple clients. It doesn't actually take this long.
Maybe it's just demos. Like you have to pay demo gods before delivering a demo. So
Okay, how will
there's
serverless
again.
applications benefit from RDS proxy? Like the main use case of RDS proxy is managing your DB connection. So if you see whether it's your serverless application or servers hosted on server on-prem, it doesn't matter. It's the basic use case of it. It's to manage your database connection. Whether you have huge number of requests, a database request via serverless or via a stateless application, it doesn't matter. Let me scroll through the list if I can find some more questions. Yeah, so there is one question from Prakash again, which says we just need to replace the proxy endpoint instead of database endpoint, right? Yes, but again, as I have shown in the script, if you want to actually secure your connection, then it's better. Or if you don't want to hard code your credentials as well, then it's better than you create your RDS proxy with IAM integration, and you create a token whenever you need, and you pass that token with your RDS proxy connection. But if you don't want to do that within your application, you actually don't want to fiddle with your application, just replace the proxy endpoint, and that's all you need to do. Nothing else apart from that.
Cool.
As of now, it only supports MySQL and Postgres as their database engines.
Cool. So I guess we answered all the questions as well. So
We did,
thank you, slide. Yes.
Thank you so much, guys, for joining.
Yes.
And I
thank you
believe
all
this
for
must have
joining
added
in.
something to your knowledge. And have a great evening.
Cool. Thanks, Vimal, for being with us on weekend and presenting the session. It was very good. Thanks for joining in as well.
Thank you. Pleasure.
Yes. Okay, then we can call it officially end.
All right, guys. Bye-bye.
Yes. Thank you. Have a good day.